Okay, we're going to work on homework for week 1, chapter 1.1, 1.2. So, in this homework, we're going to talk about or complete questions about limit. Before I go ahead, let me explain to you what limit is about real quick so we can do homework. So limit, let's say when we have graph, look, we have the graph. Everybody is familiar, graph like this, or any type of graph. So we have it continuous, right? Okay, when we have graph like this, and then it breaks like that, there is interruption, yes? So these graphs that have interruption, or they have graphs like break like this, it's like empty circle, meaning imagine like a hole. So this is for cases like this. We're going to learn how to find the value of the function. Let's say if I take this is my x and y. For this point of x1, my y is going to be here, right? y1. Very easy. But how much is my point if my value of y, if let's say I take this point, say right in the middle where it's interruption. That's what we are going to find. Let's say it would be better to draw like this. 1 second. Okay, like that. Or how much is the value of this point? So that's where we are going to do limits. So when we have interruptions or we have so-called hole, that we call limit. We are trying to figure out limit. The function, let's say f of x1, we can also treat as a limit, but it's going to be the same as we would find to the value of in the point of x1. So regarding this notation, we are started working, and you will learn this is going to be notation of limit, understanding of limit. So let's work on homework, and as I answer, you will learn what means limit. The notation of limit, so let's see which notation is read. The limit as x approaches to 2 from the right. Okay, let me go over this one also. So x, the limit, we write down like that, limit f of x. And x can approach, let's say, a from the left side, because this is my graph, this is negative, this is positive. And if I have here hole, so it can approach to this hole from the left side, can approach from the right side. If it's approaching from the right side, I'm going to write down limit f of x. X approaches to a from positive side, from here. This will be a plus, will be a minus. Okay? Now, why do we look at the separate sides, separate ways to split into two separate ways? So everything, every science taken from life, let's say we are walking and we have in the woods and we have some hole. You can approach to that hole from one side, but it's much difficult to approach that hole from the other side, right? So we are facing two different approaches. Same way, if we model, mathematical model, it's going to be like that. From one side is one type of approach, from the other side another type of approach. Okay, that's what we need to know. And to know if this hole has any coordinate, has any value, our limit from left side has to be equal from the right side. then I can write down limit f of x, where x approaches to a, well, it's gonna exist. It's gonna, let's say, some value of b. Let's say this value of b. Okay, let me circle it. This is important. All right. So if to get the full value of the limit, we have to have from both sides, limits from both sides, we have to have equal. It's crucially important. If they are not equal, then we don't have limit. Let's say in this case we don't have limit because they are not equal. If I approach from the negative side, my value for this point x1, it's gonna be this one. Okay, but if I approach from the right side, which is gonna be with plus, this is from side of minus, my end of this graph, it's going to be here, so it's going to be this value. So because this value of c, it won't be equal value of d, that's mean in this point x1 we don't have any limit. I'll come back again, I'll repeat it one more time as we go over problems. So this is just general understanding. Therefore, notation is read that the limit from as x approaches 2 from the right side. Right side is our positive side, right? From right approaches to 0, which means in this case we are going to have limit 2 to power from the positive side, this one. Okay, let's check. Good job. Moving to next one. What do we have? The notation limit f of x is read. How we are going to read notation f of x as x approaches to 4. It's going to be limit, the limit as x approaching 4 of x. A little bit easier, we're reading a little bit easier. Limit f of x as x approaching to 4. I think that's easier. So the limit of f of x is x approaches to 4. Question number 3. Let me check. Oh, I picked incorrect. The limit is x approaching. Hold on. The limit as x approaches 4 of x. This one. Okay. It's still the limit of f of x as x approaching to 4. Okay, this one. All right. Number 3, what do we have? The notation f of x is read. I would say the limit as x approaching from the left of f of x. As x approaches 5 from the left, where is it, of f of x? Here it is. Because it's coming 5, we have 5 and index negative, right? Minus, so which means it's coming from negative side, from the left. Question number 4. Use the graph of f to find the given limits. Okay, what do we have? We need to find limit x approaches to 3. Let me open it. X approaches to 3. When my x is positive 3, let me here open it. Oh, actually here I have it already. Approaches to 3. See, we are facing just the value of 3, right? There is no any hole, no break. Break is here. Therefore, I'm going up and finding the value of x is equal 3. So let's do it. Wait, what is going to be here? 1, 2, 3. It's going to be 5, 6, 7. It's going to be 7. Y is going to be equal 7 when x is equal 3. Okay? Oops. Excellent. Moving to next question. When x is equal negative 3. Okay, let's look. X is equal negative 3. When x is equal negative 3, and what do we have? It approaches from, from both sides approaches. Okay, so let's do it. It's something similar as we have, with the differences here. We have also circle, also hole. Okay, I'm going to, okay, so the graph is gonna go from here to here and come here. And here we have what value? Negative 3. So let's see. Since we are going to find limit f of x when x approaches to negative 3, so we don't have from right side or from left side. Therefore, we need to check both sides. And why we need to check both sides, from plus and from minus? Because at the point of negative 3, here we have break. Therefore, we have to check from both sides. Okay? So, what is going to happen? If I take from negative sides, let's say limit f of x, x approaches to negative 3 from negative side. So negative 3 from negative side, it's this is this graph, right? On negative side. And the point is going to be here. So if you look on the graph, let's go look on the graph. How much we are getting for negative 3? I'm getting 4. Okay. Now, if I look from the positive 3, this is going to be at the point of negative 3. I'm getting positive 1. Let me show you here. Here, from positive side. This is, we said it's going to be positive. How much was that? Positive 3? Forgot. No, positive 4. Okay. Y is going to be positive 4 at the point of negative 3. When x approaching to negative 3 from negative side, from minus, side of minus. Okay? So it's going to be positive 4. Now, from positive side, when it's approaching from positive side, we are getting how much? We got there positive 1, right? I think. Let's double check. Yeah, from negative 3, we are getting positive 1. Okay, so as you can see, these are not equal. 4 cannot be equal 1. Therefore, we can insist that there is no limit in the point negative 3. The limit does not exist. Moving to next one, number 6. Now, don't get scared, since we have a lot of questions here, this 125, because this is we are practicing, because limit topic is very confusing. That's why I load it, and we are not solving any long doing any long calculation, just looking at the graph, deciding. In return, some other problems you will have much less, 8, 9, or 10 questions. So don't draw conclusion that every single assignment is going to be this long. Absolutely not. So next question, what we are going to have, x approaches to 3. Again 3. Well, in this case we don't have any break, so we are taking our value of, here it is. Yeah, we are taking our value. So from what I see here, from both sides we are going to get the same value, right? Which is going to be -1. When positive 3 is, let me see. And here it is. Forgive me for not having a beautiful parabola, but that's not my goal. So my focus is on this hole. So we want to see how much is the limit. So from what I see here, from right or left, I'm going to have the same value, right? From the left, negative side, when it's approaching, x is equal 3. X approaches to 3 from negative side, it's going to be, see here, this point 0. From this side, x approaches, let me rewrite it so it will be better. X approaches to 3 from the negative side, it equals 0. As x approaches to 3 from the positive side, here is graph, right? From the positive side, it still approaches to 0. Which means we have f of x limit when x approaches to 3 from negative side is equal 0, and limit f of x when x approaches to 3 from positive side is still equal 0. That means there is equal sign between them, and that means we have limit in the air, and limit is going to be equal 0. In this case, I put 0 there. In this case, we have -1. See, this circle has y in the point -1. Okay. So I'm putting -1. Okay, where is negative? Here, -1. Bingo. Moving to next question. Okay, here we have one-sided limit. So x approaches to -2 from negative side. X approaches to -2. -2, that's where the break is. And approaches from negative side to -2. From negative side, when approach, it's hitting this filled up circle, right? This one. Let me show you real quick. This point, right? From negative side. Therefore, if I look on the graph, the answer is going to be 5, 4. Coming down 4. So it's a one-side limit, and asking answer, we put 4. If it would ask it just only x approaches to -2, then we would say there is no limit, because from positive side would get lower value, would get somewhere 3 or something. But it's from one-sided, it does exist. Next question. Again, one-sided. So limit of f of x, x approaches to -7 from the left, because we have approaches -7 from negative side. -7 from the left. Where is my -7? -7 is falling right where the break is. Since it's coming from the left, so it's going to be this filled up circle, right? Which is going to be, the y value of it is going to be 5, +5. Okay. And we put 5. Fantastic. Question number 9. So x approaches to 2. This is question 9. Approaches to 2. Let's see. Since asking for 2 doesn't suggest from left or right side, we have that mean to have any value of limit, both sides have to be equal to each other. Let's see. Positive 2. Where is my positive 2? Here it is, where the break is, right? So if I approach from negative sides, it's going to be this open circle of this the linear equation, which is going to be that circle, open circle is going to be 6. Okay, next we have the point here, full point. We have 3 graphs. One is a line, the other one is point, and the third one is right graph. So the graph of this linear graph is going to be 6 because this open circle is 6. And then we have point, the value of this point in the when x is equal to, it's going to be positive 1, as you can see. And the value of x is equal to for the right graph, as we can see, and approaches from positive side, it's going to be the circle, it's going to be negative 2. So shortly saying, we have a mess. We have positive 6, we have positive 2, we have negative 2, which means it's very easy. There is no limit. Does not exist. Okay? Next. Question number 10. What do we have here? Okay, one side limit. X approaches to 4 from the positive side. Okay, x approaches to 4. So 4, that's where the right graph crossing in the point of y is equal 0, right? Here it is. This is your point 4. From the positive side, which means your y is going to be equal 0 because the 4 is at the graph at the point of 4 crossing x-axis. So it's going to be 0. Moving to next question. Now we need to find out limit for x approaches to 1. Okay, so here remember we have to get the case when both sides limit are going to be equal to each other. Let's see, positive 1. Okay, my positive 1, I see from the left side where the negative is, it's doesn't have any value, right? From the right side, when it's coming from the side of plus, how much it's going to be? It's going to be positive, wait, we have 1 second. Yeah, 1. From the positive side, when it's approaching to 1, it's uninterrupted graph practically. We have the value of it is 1. When x is equal 1, y is equal 1. So if I approach from the right side, it's going to be equal 1. If I approach from left side, although first graph is ends at point 4, at point 2, y is equal 2. But we have the other graph, there is still continuation to the point. Let me explain. This is what we have. We have this graph coming here. This is 4, let's say. Whatever, it's not important. And here we have such graph. and here is circle. Now I don't remember here is what it is in this end, but and it's not important because our subject of interest is 1. That's what we are interested. So if it comes from here, positive side, the limit f of x when x approaches to 1 from positive side, it's going to be, I believe there was 1. We will double check. From the left side, limit f of x when approaches x to 1 from the negative side. Yes, if we come from negative side, this graph is ending, but this graph is starting and continuing all the way to here. The other time we couldn't do that because it was asking, let's say graph was like this and it was starting from this point and it was asking x at this point exactly. That's why we couldn't do it. But here we have shifting. Okay, we have shifting. It started from here. That's why we can come all the way to here. This is the point we are interested. And it's going to be the same positive 1, which means negative is equal positive. All we have to do is just confirm on the y-axis it was value 1. Well, just double check, no problem. For point of 1, yes, we have 1. Okay. So let me put this is 1. Why is it wrong? X approaches to 1. Okay, let's open one more time. This is my point 1. From the left side it's coming. It's even uninterrupted. I don't have any interruption there. That's very weird. Okay, let's see. I'm going to get the answer. Let me see what it's going to give answer. I'm curious. It twice and third time will give me answer. 1/2. Gee. Indeed. Okay, my fault. I didn't look carefully. Since, okay, all right, since this is 2, so half of it, okay. It's 1 and 1/2, okay. Let me see what's happening. Let me explain. So if this is 2, and this is gonna be 1, right? Half of it, so this one is gonna be 1/2. I didn't pay attention. I was counting one by one and I thought, okay, we understood. All right, we are good. Moving to next question. Question number 12. So I'm going to go faster because we already did a lot of these limits, and the reason I spent so much time because limit is a topic a lot of students are getting confused. So I'm spending time make sure we understand well. So we need limit x age of x when x approaches to -2. Let's see. -2. Here we have x is equal -2, and we have a straight line, and we have the hole in there. So because it's a straight line, so from both sides it's going to approach to -2, right? If you look at this right-sided graph, it's falling out. It's not our interest because we're looking to -2. Okay, point that is laying completely on the linear graph. So from both sides, right side, left side, it's going to be the value of +1 this time. Okay, I'm right, +1. So we put 1. And let's check. Question number 13. So 0 from the negative sides. Now this is interesting, approaching to 0 from the negative side. So 0, point of 0, it's like right in the center, right? From negative side, when we look for approaching 0 from the negative side, here is 0. Let me clean all this. This is my 0. And from negative side, it's going to be this point, right? So let's see how much was value. It's 4. Precisely 4. Negative. From negative side. Okay. We put 4. Next, number 14. X approaches to 1. So we have to look from both sides. Okay, let's see. 1. Okay, so it's right in the middle of break. So when I look on the graph, I already can see limit doesn't exist, because from the left side, the value of y is going to be that filled up point, which is equal 3. And from the right side, from the right side it's going to be 1. Hold on, let me do it. 1 and then 3. So this is, I'm going to draw again. And this is our point we are interested. And that was how much? That was 1. Okay, this is 1. So from left side, if I come, it's going to be this point, right? Which is this value. I don't know on the graph what is. But if I come from the right, it's going to be this value, right? In the point of 1. So therefore, they are not equal to each other. Say A. A is not equal to B. Therefore, there is no limit. Number 15. X to negative 5. Oh, without even opening zooming, I can say there is no limit. Why? Because x of negative 5. Where is my negative 5? It's right here on the left side, negative 5. So the graphs that have two completely different y's there. Okay. Limit doesn't exist. Pretty straightforward already. Hopefully you also started feeling comfortable. Now next one, limit of age of x when x approaches to 6. Okay, we need full limit, both sides that have to be equal to each other, is equal 6. When, okay, x is equal 6, it's sitting on the same graph, and there is just a hole at the point of 6, and from left side, from right side, it's going to be the same value 5. Let me show real quick. Say it's coming here, and here is circle. So this is 6. So if you come from the left side, which means it's approaching from here, from the right side, it's approaching from here, it's going to be same value, right? And that value is 5, positive 5. Moving to next one, number 17. We have about 8 questions. We will go over easily because, yeah, we have there some algebraic way also. We'll take care of it. So this is question number 17. I think it's the same thing. Let me see. X approaches to 6, so both-sided. Approaches to 6, yeah, again, both-sided, and it's going to be 0, right? From left, from right, it's going to be 0. It's clear. x approaches to infinity. Okay, this is interesting case. X approaches to infinity, that means it's going to the right all the way. Yes? When it approaches to infinity, what do we have? This our, the very right side graph is approaching to 0, right? Y is equal 0 as it approaching to infinity. So the y is going to be value 0. The middle graph is also, okay, middle graph, x approaches, x goes to infinity, it approaches to y. Okay, let me explain. We have this. We have this graph, and then we have there something like this. Okay, this is our infinity, right? When x approaches infinity, we have this graph affected by infinity, right? And where is it running? It's running to 0. Yes? So therefore, our value is going to be 0. And from both sides, from the left and from the right, it's still going to be, look, if I come from this side, it's still going to go to infinite 0. 19. Here it is. Here we are going to do algebraically. So limit you can find not only by graphing through the graph, but algebraically also. As you noticed, everything you can do by graph and by in algebra. So the bottom line is what we are doing here. We are going to, it's x approaching to 2. So all I'm going to do is plug positive 2 into x. So first one is going to be 2 squared. It's going to be 4, and this negative, since x not in the parentheses separate. One thing is very confusing for students, I'm going to remind it from algebra. X is equal to, so if I have negative x squared, it's going to be negative 4, because it's going to be negative 2 squared. But if when x is equal to, and I would have negative x squared, that would be different story. I would have, it should be positive, x2, but x is in parentheses, it's going to be negative 2 squared, and that would be positive 4, you see? So now because we here have negative is not, doesn't belong to x, it's like negative 1 times x squared. Therefore, I'm raising 2 to power 2 is 4, and then put negative sign in front. So here we have first term, we have negative 4. Second one will be 3 times 2 is 6. Negative 4 plus 6 is positive 2. And 2 minus 5 is 3. What? Let's do over again. 2 squared is 4, so negative 4. Negative 4 plus 3 times 2 is 6. Negative 4 and plus 6 is positive 2. Minus 3, duh. Not paying attention. Okay, we are going to do next one is 1. So I'm just dropping everything because x 1 to power 5, 1 to power 3, it's same 1. It's going to be 2 minus 6 is negative 4. Negative 4 plus 8 is positive 4. Okay, 21. Okay, in the case of 21, I am going to plug in again and let's see what we're gonna get. Okay, in this case, how we gonna solve? We're gonna do fill answers. We need to find the limit. Okay, so let me write down this problem and then I'll solve it. Where is my phone? I'll take the picture of it so I can do it on the draft. 1 second, let me take the picture of it. All right, let's go to solve it. So we have limit x approaches to 2, and we have x squared plus 2x minus 8, and here we have x squared minus 4x plus 4. Okay, let's see what we are going to do here. So x squared minus 4x plus 4. I can break it down. Let's break down this one also. Foil it down. X squared plus 2x minus 8. How can I foil it down? X plus 4 and x minus 2. Yeah. Guys, if anybody doesn't remember how to do that, I have a video, I think quadratic expressions, quadratic equations, and I cover there this method, okay? Whoever want a link to that, I will send it to you. Contact me, I will send it to you. X plus 4, x minus 2. So just real quick to remind you, 4 times negative 2, we are getting negative 8. And 4 and negative 2 together is positive 2. That's how we did. Now, x squared minus 4x plus 4, it's going to be x minus 2 times x minus 2. Negative 2 times negative 2, where I'm getting positive 4. And negative 2 put together, I'm getting negative 4. Okay? So, what we are getting from here, negative x minus 2, I am cancelling with x minus 2, and I am ending up with limit x approaches to 2, x plus 4 over x minus 2. Now I need to plug 2 here. So when I plug these 2 here, on the top I'm getting 6. When I plug this 2 here, I'm getting 0. I cannot divide by 0, therefore limit does not exist. Okay? Or, if the other easier way, just plug here the 2 squared minus 4 times 2 and plus 4. This is 4, and then minus 8, we get negative 4, and plus 4 is 0. The thing is, sometimes you can get over it. Sometimes when denominator at the beginning it becomes 0, at the end you can cancel, blah, 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 and not necessarily get division by 0. But this time, yes, we get it. So that's why I went through opening, foiling, and so on, so you would know the procedure. Okay. Limit doesn't exist. Question number 22. 3 questions left, hang in there. Okay, what do we have here? This is more interesting. Use the limit properties to find the following limit. how we are going to do, what's the property of limit? I'm going to explain. So let's assume I have the following limit. A x to power m plus blah 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 blah, it doesn't matter. And b x to power n plus blah 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 blah. Okay, so here is a case. So first case, if m is equal n, meaning degree of x's, numerator and denominator are equal, then the limit of x approaches to infinity, as we had, it's going to be equal a over b. Second case, if m, degree m is less than degree n, then the limit, let me put here f of x, I'm sorry, x approaches to infinity, f of x is going to be equal 0. And third case, so if m is greater than n, what do we get? Improper fraction, right? Higher degree than the denominator. Improper fraction, that means limit does not exist. Doesn't exist. So in our case, it was degree 1, right? Both cases. See, we have 8x, which x has degree 1. And 7x also has degree 1. When degrees are equal, then the limit equal a over b. My a is 8, b is 7. Coefficient, I'm taking coefficient of x. So therefore, it's going to be 8. If I put forward slash, it will bring me division. Where is my forward slash? Here it is. Over 7. Those are not available terms, 8 over 7. Those are coefficients of x's. What's uncomfortable problem? It's and coefficient of x is 8 and coefficient and available term is 8. No, you are taking coefficient of x. You are working with coefficient of x. And this is great. Let's go back. We have it equal, right? Hold on. Type integer or decimal. Okay. We need to divide 8 over 7. That's why it says wrong. 8 over 7 we divide. Let me see how much we are going to get. A divided 7, I get the whole 9 yards, the decimal digit rounded to nearest 1,000, so we need practically 3 digits. And it's going to be 1.143. I'm rounding because 8 is following there. 143. Oops. Okay, fantastic. 2223. Okay, what do we have here? So we have, what do we have? We have on the top the highest degree x cubed. Keep in mind, if you have you have here trinomial, you have degree 3, degree 2, degree 1. You always comparing highest degree of the top with the bottom. The highest degree is 3, 14x cubed. Bottom also highest degree is 3. So degrees are equal, which means we are taking coefficients of this x's. 14 over 21. But I am going to reduce by 7, both of them, and getting 2 over 3. What does it want in this case? Does it want regular fraction? Approaches, it doesn't exist. what does it say here? It doesn't say anything, so I can put the answer 2 over 3. It doesn't say to round to convert into decimal. Okay. 24. Determine whether the function is continuous in interval -6, +6. Let's see. From -6 to +6. Oh, at the point -1 we have break, right? So it's not continuous, no. And the very last one, congratulations with your patience. Let's do it. Wow. Yeah, at the end we have to go through 4 cases. We'll do it. We'll do it. We're already doing well. I believe I saw so many limits that you're already doing well. For the point -1, x approaches to 1 from negative sides. So I'm zooming here. X approaches to 1 from negative side. So value of y is going to be +3, right? That's the graph with the filled up circle, right? +1 approaches from -1. It's equal 3. Good luck. Oh God, why did I put -3? Well, do you think only you have enough? Come to me, I'll tell you how much I have enough. That's the result, -3. Staring at +3, typing -3. All right. Next one. We have limit f of x, x approaches to 1 from the positive side. From the positive side, we are facing here this empty circle, right? From the +1 approaches to 1. So, and the y is going to be 2. And last one, we have f of 1. So, the value f of 1. How much is the value of f of 1? Let me see. If I take f of 1, it's going to be 3. Why not 2? Because it's asking, doesn't ask for limit. See, it's just asking. Oh, wait a minute. That is, I thought I'm doing D. So I'm still at C. So on both sides, okay, it's asking limit x approaches to 1. So we did one-sided. S of the limit of 1 from positive side is 2, from negative side is 3. See, I'm looking at A and B cases. Therefore, doesn't exist, right? Okay. And lastly, D. See, it's asking f of 1. There is no limit. I just need to know if x is equal 1, how much is my y? So let's go and see. When x is equal 1, I am going to take this filled up circle, not the hole, because that's a hole. Okay? To get the real value, it's a continuous value. That's the 3. When x is equal 1, y is equal 3, because it's filled up. It's a point. It's a continuous graph ends with filled up point. So I put 3. Doesn't seems to me that it's, hold on. Okay. That's it. We are done. So congratulations with your patience. So I believe this is the longest assignment that you have in this course. Further will be shorter list. All right. Contact me if you have any questions. See you at next the assignment.